Hi guys, welcome to Amateur Chemistry. So, in today's video, I will be transforming some dirt into pure silicon dioxide, which I will use to make some elemental silicon and silane in future videos. Silicon dioxide is a major component of most rocks, sands and glass, and it is just extremely abundant. However, it is pretty rarely naturally found in its pure form, and the most common place where you can find impure silicon dioxide is literally the ground. Soil is composed of many things like organic matter and minerals, but its biggest component is sand, which is made almost entirely from silicon dioxide. It isn't particularly hard to chemically extract it from sand, but since where I live there is almost no sand, I decided to use some dirt because it still contains a lot of it and should be reasonably easy to process. To start the extraction, I of course need to get some dirt, and to do that, I firstly have to go outside. After a bit of hesitation, I am now outside, and the first thing that I did was to of course touch some grass, which was a pretty interesting experience, and after that, I found myself a path of exposed soil, got a shovel along with a metal bowl, and started to dig up some of it. I know that getting reagents from the ground is a pretty nice thing, but when your reagent is literally the ground, you have really achieved peak chemistry. Anyway, after getting the dirt into the bowl, it was well pretty dirty, because along with my precious sand, it also contained tons of organic impurities. To remove most of them, I got myself a metal sieve and passed the dirt through it. After this operation, it was much cleaner, and now I was left with some technical grade dirt. I wanted to make it even cleaner, so I passed it through the sieve once again, and now I was left with 0.999 fine laboratory grade analytical dirt, and before I go and process it, I firstly wanted to weigh it to calculate how much silicon dioxide I got out of it later on. I weighed out 300 grams of it and proceeded to use them for the extraction. The first step in extracting pure silicon dioxide from dirt is to wash it several times with water to remove most of the water-soluble junk. To do that, I just poured a generous amount of water onto my dirt, stirred it, allowed the sand to settle down, and decanted the water off. I did a total of 4 washings, and after the last one, the sand looked a bit brighter. I then wanted to vacuum filter it to get rid of the last soluble impurities, but my vacuum pump mysteriously broke, and that was very bad, but my dad came to fix it, and now it runs even better than before, so thanks Dad. Anyway, after the filtration was done, I transferred all of the sand into a beaker, and now it was time to chemically remove more of the impurities. The thing is that lots of them don't dissolve in water, and to dissolve them, I need to use some concentrated hydrochloric acid, which will leave the sand behind and destroy everything else. I poured 100 ml of 30% hydrochloric acid onto the sand, and it immediately started to react and made the whole mixture turn a green color. I then added another 50 ml of the acid for good measure and placed the whole reaction mix on a hot plate. I tried to stir it with my new big stirring rod, but it was still too small, so it just sat there. To speed up the reaction, I turned on the heating and put a flask with cold water on top of the beaker to condense any acid vapors, creating an improvised reflux. What is going on here is that the acid dissolves everything organic and mineral, while leaving behind just the sand. After about 30 minutes of refluxing, I took the beaker off the heat, decanted most of the acid, and poured in a lot of distilled water to dilute the rest. The sand was now much clearer and had a grey color. I then vacuum filtered it to wash away the last bits of the acid and got it into an oven to dry, because for the next step it needs to be really dry. After about an hour in the oven, it looked just like your average sand, but this sand is special because it used to be just some random dirt. It is really pure and low in contamination, which makes it perfect for the next step. And speaking of that, I now have to react it with molten sodium hydroxide to make something called sodium silicate, which will let me purify the sand even more. I have to do this reaction in a steel container because molten sodium hydroxide eats glass very easily, and that is essentially what I am using it for right now. I firstly wanted to use this small and rusty steel paint can, but after cleaning it up, I found out that it had the texture of Swiss cheese, and I had to find something else. I found this old cat food can, which will be perfect for this reaction. After cleaning it up, I poured in 140 grams of my sand, followed by 80 grams of sodium hydroxide, and mixed them thoroughly using a metal spatula. I then got my rusty electric stove, placed the can on it, and cranked up the heating. This reaction only occurs when the sodium hydroxide melts, and its melting point is 318 degrees Celsius, and this temperature is much below that of my hot plate, so I thought that it would react quite fast, but after heating it for a while, nothing seemed to happen. I thought that the temperature wasn't high enough, so I brought out the big guns in the form of an old gas stove. I placed the can on it and started to heat it quite vigorously, but still nothing happened. When I watched videos of other people doing this reaction, the ingredients always melted, creating a kind of slurry that then hardened upon cooling. My reaction mix just stayed as a powder, and even when the can got red hot, it didn't melt. After a few minutes of vigorous heating, I got it off the heat and spread it on a piece of metal to cool. The product looks similar to the starting sand, just a little whiter, and I honestly didn't know if the reaction even worked. To find out, I got all of the reaction mix into a beaker, followed by a generous amount of distilled water. What I wanted to see was a complete dissolvement of the material, but instead, only about half of it disappeared, and the other half stayed behind. This was partially a good sign, since the sodium silicate is soluble in water, but since not everything dissolved, it told me that there was less sodium hydroxide that was necessary to react with everything. Anyway, I filtered the solution, and now for the final test that will tell me that the reaction had worked, I poured in a few milliliters of 50% sulfuric acid. Almost instantly, a goopy crust started to form, and it was the silicon dioxide. This told me that the reaction worked only partially, and in the future I should probably add more sodium hydroxide. I continued to add more sulfuric acid to the beaker, and when the solution got too thick, I added some more water to dilute it up a bit. What is going on here is that the sulfuric acid reacts with the sodium silicate, producing insoluble silicon dioxide and sodium sulfate. The silicon dioxide precipitates out as a solid, and in the presence of sulfuric acid, it forms something called silicic acid, which is very gelatinous and is responsible for the thickening of the mixture. After adding all of the acid, the mixture looks like the one from the chemical garden video, and now I have to filter it. I tried to use a vacuum filter, but it didn't work, so I proceeded to use a coffee filter, and after a night of filtering, I was left with a reasonably dry silicon dioxide jelly. I now had to dry it to convert the silicic acid back into silicon dioxide, and to do that, I got it onto a sheet of aluminum foil and put it into the oven for a few hours. The high heat turns the silicic acid into silicon dioxide, which turns into a white clumpy powder. I then have to wash this powder with water to remove any residual contaminants and dry it again. After the drying, I had about 16 grams of it, which wasn't a lot, but I still had to process the second batch of the sodium silicate solution, and to do that, I just repeated all of the previous steps. After I processed all the silicate, I was left with a total of 65 grams of pure silicon dioxide, which wasn't a lot, but considering that I miscalculated the amount of sand that I had to use, and used around twice as much, this was actually a pretty decent yield. As I said previously, I plan to use this silicon dioxide to make some elemental silicon and silane in future videos, so if you don't want to miss out on them, you can subscribe to my channel. And before I end this video, I just wanted to let you know that I have a Patreon now, and if you want to support my channel and gain access to some spicier videos, you can become a Patreon. Actually, I already have a single Patreon, to whom I am very thankful for becoming the first one, so thank you very much R2D2, and see you guys in the next video.